The next thing I would like to show you is called Euclidean sequences. It's a technology or a strategy for creating grooves and rhythms, especially for percussive elements such as hi-hats, snares, or claps. It's a tool that can help you overcome stale rhythms, kind of 4-to-the-floor rhythms. So whenever you feel your rhythm lacks groove or isn't really interesting, then this technology can help you to create something truly unique and something that you probably would have not created by yourself. So this is another technology tool for helping you in music production, especially when it comes to beat making. It exists as a hardware device, which is what I'm going to use here in the first part of this chapter, a dedicated hardware device for creating these rhythms. Later, we will look at plugins for Ableton that have the exact same functionality, but I will be explaining the baseline concept here on the modular with this hardware device, which is called Euclidean Circles, and it's manufactured by a small, bespoke German company that makes wonderful modules for the modular. They're called vpme.de. Highly recommended. Why are Euclidean sequences called Euclidean sequences, and what the hell are they? In the 90s, a French mathematician and computer scientist discovered that you can formulate any musical rhythm that is played on a single instrument, like, for example, a kick drum hit or the hit on a snare, as a mathematical algorithm with only 3 parameters. The first parameter is the length of the rhythm counted in beats. For example, 16, like as in 16/16ths notes or steps if you want. The second parameter is what's called fill, and that's the number of beats within the length of this pattern that are being played. And most importantly, these fills are distributed as equally as possible. So for example, if I have a rhythm that's 16 steps long and I put in 4 fills, sometimes also called hits, that means I have 4 hits across 16 steps that are distributed evenly, which is basically your 4-to-the-floor kick drum rhythm of techno or house. The last parameter is called shift, or most of the time it's called shift, and which means is how many steps of the rhythm is moved to the right starting from the beginning. So in other words, your classical 4-to-the-floor kick drum downbeat rhythm expressed as a Euclidean sequence would be 16/4/0, which means the beat is 16 steps long. Within this 16-step sequence, you have 4 hits, and the first hits starts on the very first note. So there's no lag, and that's why the last number is 0. So 16/4/0 gives you your standard 4-to-the-floor kick drum rhythm. And with the Euclidean Circles module, as with any Euclidean sequencer, what you can do is you can dial in these 3 numbers and get an encoding rhythm. And they all sound nice because they adhere to the principle that the number of fills has to be distributed as evenly as possible. And that is something, at least to Western ears, that makes a rhythm. And this is perfect for closed hi-hats and claps and snares. You always need a bit of structure to hold it all together, like a 4-to-the-floor kick. But then you can distribute Euclidean elements within that. Let me show you. I'm pressing play on my modular synth, and that will give us a 4-to-the-floor kick. There it is, a 4 to the floor basic kick. Now, what I will do is I will supply 16 clock pulses to the Euclidean circles module by attaching a clock signal to the clock input. And you can see the circles start rotating. Each circle is one Euclidean rhythm. Let's start with the top one. As you can see, it's 16 blue LEDs that are lit up. I can change the number of LEDs that are lit up by turning the button to the left. And as you can see now, some of the LEDs go dark, which means they're off, they're no longer part of the sequence, so I'm basically shortening the rhythm. So by turning it here, we're now at 7 steps, an unequal number of steps in the rhythm. And I can now start fill these steps. So when I click again, it will, I need to click until it's yellow, and now it expects me to dial in the number of hits. And as you can see now, there's 1, and then there's 2, and there's 3, and there's 4, distributed as evenly as possible across the 7 steps. You can't hear it yet because I haven't connected a sound source. So let's do that.